Good morning, good afternoon, or good evening, everyone, based on the time zone you are in. I am Neil Mitra. I'm an enterprise solutions architect with AWS. I would like to welcome all of you to this session of Bring IoT and AI Together. I have been fortunate to help various customers build IoT and AI applications on AWS, and I'm happy to share my experience with you all today. If you are excited about IoT or AI or both of these technologies, then you are at the right place. Just wear your seatbelt and let's take the ride. We'll start with an overview of AWS IoT and AI services. We'll then explore how the combination of these two powerful technologies is enabling customers with different use cases. We'll also discuss a case study from our customer, Sentient Science. And before we let you go, we'll also do a Q&A with you all. At AWS, we always start our customer engagements for IoT with a simple question. If you knew the state of everything and could reason on top of that data, what problems would you solve? And we ask this question because we made it our mission for the last few years to ensure we build for you the right tools, the processes, and share with you the best practices for you to know the state of everything, of all your devices, and that you can reason on top of that data so that you can truly solve your business problems. We had been trusted by our customers of all sizes across all different sectors to help them solve their business problems. If you think about customers like Vizio, they selected AWS IoT Core for their complete line of smart TVs and soundbars, including a new line of TVs that launched during the holidays. They have rolled out millions of devices today. If you think about a customer like iRobot, they uses AWS IoT and other services to power its Roomba vacuum cleaners, which have mapped more than 500 million square feet of floor space as part of the company's smart home vision till date. My personal favorite, Fender, they use AWS services, including IoT Greengrass, to provide quality assurance in the wood matching process when they manufacture their guitars. And you can see many other customers here like Philips and GE and Enel and Pentair who are using AWS to solve their business problems for different use cases. And if you think about these use cases, it seems that cloud and AWS IoT has become the new normal for their business. If you think about a use case like predictive maintenance, a customer like KMP, they used AWS for its flagship welding machine, and they were able to cut the cost of software development by approx 50%. If you think about the use case of wellness and health, we have customers like Philips. They build their health suite digital platform on AWS to solve the challenges of connecting and supporting healthcare devices. If you think about the use case of energy and efficiency monitor, customer like Enel, they're multinational manufacturer and distributor of electricity and gas that serves 61 million customers. Enel reduced the provisioning time of their field assets from 4 weeks to 2 days, using AWS as its platform for IoT and energy management. They're solving their business problems too. Any other use cases like connected buildings and city, we have customers like MyoVision. Device fleet maintenance, we have customers like Trimble. Payment and insurance, we have customers like LendUp. Manufacturing facilities, we have customers like SolarNow. And there are tons of other examples and use cases how AWS IoT is helping customers today. So if you think about all these use cases, IoT is essentially helping you, our customers, with two areas of the business equation. The first area, it helps with the top line. It means it helps you to generate new revenue. launching new products, launching new services, launching new business models. It also helps you with the better customer experience. If you think about our customer like Vizio, with their smart suite of televisions and soundbars, they are reimagining their engagement models with the customer. The second area of the business equation where AWS IoT helps you is with the bottom line. So how can you improve your profitability or operational efficiency? If you think of a customer like Chai Point, they're able to optimize their entire supply chain, which enable them to monitor hundreds of retail stores in real time. So you can imagine customers like you are not buying an IoT technology. They are seeking business outcomes. So now we understand the business values and some of the use cases. Let's talk about the tech. Traditionally, IoT solutions are multidimensional and therefore can be complicated. If you think about the different layers of an IoT solution, it starts with the edge and the provisioning layer on the left. This is where you onboard your assets or devices, you operate them, you manage them at scale. The second layer is a communications layer. This handles the connectivity, the message routing among the devices, or between the devices and the cloud. The third layer is the ingestion and the analytics layer. This is where all your data is collected, it's aggregated from all the different data streams created by your devices so that you can analyze the data, visualize the data, and perform machine learning on top of it. The fourth layer is the application layer. This is where you might have different kind of applications. You might have user applications. So you enable other internal and external systems using different segments of the IoT data for building different applications. Or you might have management applications, which helps you to have scalable ways to operate your devices securely once they're deployed in the field. And finally, you will align to various ITIL practices for event management, change management, incident management, just like you do for any other IT workloads. So how does AWS support customers like you with all these building blocks? And that's what we refer to as the fundamentals of AWS IoT. Let's look into it. The logical view. First, you have the edge layer. This is where you have the devices running the device software for you to connect to your sensors or actuators on your assets. The middle layer is the communication layer. This is where we have the control services for the assets to be controlled and managed securely from the cloud. And top of the stack is a data layer. This is where we have the data services. So you are not doing all this work just for fun, right? You need these services to extract meaningful information from your data. In the last few years, we have been working backwards with our customers like you, and we developed different services across all of these three layers. So at the device layer, we have a service called Amazon FreeRTOS. It's essentially an operating system for microcontrollers that can be found in many devices, including appliances and sensors and fitness trackers and whatnot. Amazon FreeRTOS is optimized for microcontrollers with greater than 25 megahertz of processing speed and greater than 64 KB of RAM. It can directly connect to the cloud services or to more powerful edge devices running AWS Greengrass. So what is Greengrass? Greengrass is a service as well that brings local compute, messaging, data caching, sync, and machine learning capabilities to the edge devices. AWS Greengrass requires at least 1 gigahertz of compute. It can run either on ARM or x86 architecture. It can support both 32-bit and 64-bit operating systems, and it needs a minimum of 128 MB of RAM. So you can imagine it can run on devices that can range from a Raspberry Pi to a server level appliance. It can act as a device on its own or as an edge gateway to connect to various cloud services like AWS IoT Core. So now let's talk about the control services layer. AWS IoT Core, if you're not aware, is the first service that we launched in 2015. It's a managed service that acts as a gateway to support billions of devices and trillions of messages, and can route these messages using rules engine capability to other AWS services as well. IoT Core also brings with it a device shadow and a device registry capability. Now, the obvious question is, I have billions of devices, how do I manage it? That's where we launched a service called IoT Device Management. This helps you to organize and manage your devices so you can do over-the-air upgrades for different patches or firmwares or any custom jobs. Now, our customer told us this is great. We are able to now manage millions of devices, but how do we do that securely? And that's where we launched the service IoT Device Defender. It continuously audits your IoT configurations on the devices to ensure that the devices are not tampered with. They are not deviating from the security best practices. And finally, IoT Things Graph. This is where customers like you told us, all this is good, but how can you help us to rapidly build IoT applications by connecting devices and the web services that might speak different protocols that might not work with each other out of the box? And that is the problem that IoT Things Graph intends to solve. Now, let's talk about the top layer of the stack, the data services layer. This is where we have built services like IoT Analytics. This is a service that collects, preprocesses, enriches, stores time series data in a time series optimized data store. IoT Analytics can perform simple as well as complex analysis using SQL and containerized datasets. IoT Events helps continuously monitor equipment and fleets of devices for failure or changes in operation and trigger alerts to respond when events occur. And finally, IoT Sidewise. This helps you to collect and organize data from industrial equipment at scale to identify waste, such as breakdown of the equipment, production inefficiencies, or defects in the products. So if you are running SCADA or PLCs, this service might be helpful to you. So you can imagine what we're trying to do is to remove the complexity of implementing IoT into the business in a scalable way. You can securely connect any number of devices to the cloud. We provide you the infrastructure to scale. And so you can focus into your data to build application that matters for your business and also helps you to continue with the culture of innovation. That being said, we don't want you to believe that this is a standard hardware stack. It's much better thought of as a cycle. So it starts with the device layer where you have the device software. So you collect the data locally from the devices using your sensors. Then you have the control services again, which helps you to send the data to the cloud. And you use data services to get insights from those data so that you can take the better actions. And based on your learning from all these insights, you go back to the devices, collect more data that is needed, and get more insights. And that is why we refer to this as an IoT virtuous cycle. This is not a one-time process. It's an ongoing process which helps you to build new services, new revenue models, or optimize your products and services similar to the way that Roomba and Fender and Philips are doing it today. So now you have learned about the AWS IoT ecosystem and three key layers. Let's also talk about the AI stack or the machine learning stack. And guess what? These also have three key layers. The bottom layer is referred to as the machine learning frameworks. This is for the expert machine learning practitioners, researchers, and developers. These are the people who are comfortable building models, tuning models, training models, figuring out how to deploy them into production, and also manage it themselves. At AWS, we offer a broad array of compute options with CPU-based instances, GPU-based instances, even FPGAs. And the vast majority of machine learning in the cloud today at this layer is done through AWS AMIs or Amazon Machine Images that we build to support all the major frameworks, whether it's MXNet or TensorFlow or Scikit or PyTorch or anything that you name. The second layer is referred to as the ML services layer. So now customers like you asked us how we can help you enable more enterprises and more companies to be able to scale with machine learning, because not everyone has a lot of PhDs and data scientists to help them problem their business statements. So how can we make machine learning accessible for everyday developers and scientists? And that's when we launched a service called Amazon SageMaker, which helps you to remove the heavy lifting, complexity, and guesswork from each step of the machine learning process. SageMaker makes model building and training easier by providing pre-built development notebooks, popular machine learning algorithms, optimized for petabyte scale data sets, and automatic model tuning, which will enable you as a developer to build, train, and deploy models in a single click. SageMaker is already helping thousands of developers to easily get started with the machine learning technologies. And then the top of the layer is the AI services layer. This is where you need no ML skills. We did the work for you. We trained these models. We with hundreds of thousands of data points, and this is available for you to just use out of the box. So for example, if as a customer you say that here is an object, tell me what's in it, or here is a face, tell me who is this person, you can use a service like Amazon Recognition and it will tell you what is that. If you want to translate from text to speech, you can use a service like Amazon Polly. If you want to build a conversational chatbot, you can use a service like Amazon Lex. If you'd like to convert speech to text, you can use a service like Amazon Transcribe. If you want to translate text between different languages, you can use Amazon Translate. If you want to understand the relationships and find insights from unstructured text, you can use Amazon Comprehend. And we'll continually work on this kind of services so that we can help you quickly solve your business problems for the most common use cases. So now you learned about the IoT ecosystem and the AI ecosystem. Let's spend some time on the machines itself. So in the IoT world, your machines are the assets that you are deploying on the field. And based on the analysts' findings like Gartner, there will be trillions of connected devices around us in the near future. So as humans will be easily outpaced by all these machines. So guess what? The machines need to monitor other machines and machines need to also collaborate with other machines. So why it is a big deal? What do I mean by monitoring other machines? So if you had been in an IT world, you might know that we had been monitoring IT systems, for example, the servers and the databases and the network racks for such a long time. So what's different with machines? Let me tell you what's different. In an IoT world where you have all these machines that needs to coordinate with each other, you might have complex events from multiple sensors, multiple devices. You might have status coming in different intervals. You may not have context to the data all the time. Data might be noisy. That means full of gaps. Let's take the example of a paper mill. Let's imagine there are different type of papers coming out from a production line. There are toilet papers, there are kitchen papers, and there are other kind of papers as well. Now suddenly things slows down. And at the time, you need information from 20,000 sensors, your manufacturing systems, your ERP systems, to identify if it's a plan or an outage. And that's where machines need to be smarter and they need to use machine learning to detect all these different complex events to take the right decision. But then machines are required to take millions of decisions. And how do you determine whether it's a good decision or a bad decision? And that's where machine learning can play a major role as well. You can analyze the decisions made by your machines from time to time and figure out if those are right or wrong. And based on that, you tune your models further so that they can get efficient with time. And finally, policing. Yeah. So the machines will also have their own cops in the future. So take an example of two distributed systems, both with different optimization functions. And how do you ensure they are playing with the global rules? They're not talking their own language. And that's where policy enforcement is required as well. Okay, now I hope you understood a little bit about monitoring of machines. Let's talk about the collaboration between the machines. If you think about IoT data, it's really a hot mess because the physical world is so unpredictable and machine data is super hard to do machine learning on. That is because device data is simple. It does not carry a lot of information or context needed to interpret it. Even lot of data might have only limited relevant information. Or machines might have been deployed in areas with intermittent connectivity, so the data might be noisy, filled with gaps. Think of scenarios where you need to monitor earthquakes or forest fires. And if you have your devices there, they will have very limited connectivity and your data might be of very poor quality. Thus, machine learning can also help you in determining good quality versus poor quality of data as you go through the cleansing process so you can take actions to improve your data stream. Remember, data is the new oil. If you have good data, that's what helps you to improve your business outcomes and be successful on the field. So let's do a quick recap. So far, we discussed about the IoT ecosystem and the machine learning ecosystem as well. Now, let's see how they work together. As you can imagine, we have been very creative in coining the term AIoT. So let's talk about this scenario now. So data is collected from the devices. It's routed to the cloud where it's aggregated and enriched and cleansed. And then machine learning algorithms are applied on the data. Machine learning models are generated. And you do inferencing on the data as well. So there are two key things to remember here. First, data is more valuable when it's adjacent to other data set. Thus, you perform the analysis and machine learning in the cloud to build the models, train the models, and also you need the horsepower of the cloud to process petabytes of data or terabytes of data and generate all these models. At the edge, you cannot do that. But at the same time, you can do inferencing at the edge. And that's what opens up great capabilities for you. For example, think of self-driving cars. If they're going to crash, they cannot afford the round trip latency of the cloud to get the instruction back. They have to take the decision locally on the car itself. And how do they do that? They will do machine learning inferencing on the card, which is the edge, although that machine learning model is built and trained on the cloud. Thus, you can see that IoT and AI, IoT and machine learning together creates this AIoT virtuous cycle. And cloud and the edge, or IoT and AI, complements each other to support various use cases that was not even possible before. So now let's see how the rubber meets the road with Sentient Science, who is one of our customer, and how they have implemented the concept of AIoT in their use case. Sentient Science was founded in 2001. They have various customers in the energy space, and their goal is to facilitate frictionless onboarding of the field assets, focusing on the wind energy sector. and most importantly, also to extend the life of those fielded assets using their digital clone platform. What is a digital clone platform? This is a platform that they build which helps them to model assets like the turbines or the gears based on material science. And then on the top of material science, they also use data science using machine learning and AI capabilities, and they can predict the asset health and they can improve the reliability of all those assets on the field. So let's look into the architecture as well. On the left, you have the edge, and on the right, you have the cloud. So for the data ingestion pipeline, the wind turbines communicates to edge gateways that is running AWS IoT Greengrass via SCADA. Greengrass, in turn, uses MQTT protocol to publish all the device data to AWS IoT Core in the cloud, which, if you remember, is a managed service that can handle billions of devices and trillions of messages from the edge devices. And once the data is ingested, it's routed to the backend services through a rules engine and persisted in a data lake for data analytics and performing machine learning using Amazon SageMaker. So here you can see the data is persistent in IoT analytics, and also the data is persistent in S3. If you know about S3, it's object storage, and it has 11 nines of durability. That means if you store 1,000 objects in it, you will probably lose one in few million years. So you can see how Sentient is using IoT on the edge and AI seamlessly taking advantage of all the managed services and capabilities of the cloud. And that is helping them to drive innovation with their customers and deliver the business outcomes, and letting us, AWS, to take care of the undifferentiated heavy lifting of managing the infrastructure. In addition to the ingestion and the AI pipeline that I showed you, they have also built various other models for data consumption, from reporting to transaction monitoring to custom security enablement, etc. This is a pretty cool story, and if you want to learn more about this use case, you can check the reInvent session from 2018. It's in YouTube. The title of the session is Help Customers Harness the Power of Connected IoT Devices. So to summarize, you learn about the building blocks of AWS IoT and AI ecosystem. You learn how customers like GE and Fender and Philips are using these building blocks to solve various business problems. You also heard about a specific case study from our customer Sentient Science. And now I can't wait to see what you are going to build on AWS, because AWS is all about how. Thanks for being patient with me, and thanks for joining the session. Please do not forget to share your feedback, what you liked or disliked about this Tech Talk, because that will help us to improve in the future. Thank you again.